Oxidative cleavage is when oxygen breaks a bond in half. In the alkene example, we're going to cleave this double bond in two. And what will remain are double bonded oxygens, thus the term oxidative cleavage. There are a lot of different types of reactions that can undergo oxidative cleavage. We'll look at one common example of that of permanganate. And this reaction, it's basically going to be a continuation of the previous reaction that we learned about, which is syn hydroxylation. We learned that if we add permanganate, it can add hydroxyl groups to a double bond, but on the same side. That's the first step. Now, what will undergo the cleavage, if the concentration of permanganate is high and if it is warm. If it is cold and dilute, it will stop at this step right here. But if it is warm and concentrated, then it will undergo further oxidation, and that oxidation will cause it to cleave in two. So here I distinguish the right and left hand sides. It doesn't have to be like this. It can be all carbons, it can be whatever. But I added these so we can distinguish the right from the left. So we can see over here the left hand side, the R and R, the oxygen, R prime and H over here. And all that is different is instead of being double bonded to each other, they're now double bonded each individually to an oxygen. Now with this reaction, it so happens that if an aldehyde is formed, it will continue undergoing further oxidation into a carboxylic acid, but that is just unique to this reaction. It does not necessarily happen with everything. So if we write this in summation, this bond breaks in two, and it forms a ketone and a carboxylic acid, and the only reason it forms a carboxylic acid is because it undergoes further oxidation at this step. So this is one of many possible oxidative cleavages. We'll learn about different ones as we go along.